today we're going to learn about how to find the max and min of quadratics. So just a little reminder or review. A quadratic is something that looks like this. It's a function that has this shape right here. And this one is y equals x squared, something like this. And one thing you need to know about this part of the course is something called vertex form. So this is vertex form. It's h squared plus k. And it's just a form of the quadratic. And the only thing you need to know about vertex form is the values h and k. So h and k, they represent points. They represent the vertex, hence why they're called the vertex form. And the vertex is the point on the quadratic, like right here, where it's kind of where the quadratic splits off. And the vertex could be like that, where it is on the bottom. Or let me show you another example. Could also be like upside down, like something like this. This is also a quadratic. And then the vertex of this would be right here. And the point would be h and k. It'll make sense when we do an example for this. Yeah, this is the only part of the theory that you need to know. And then getting on to the math bit. So usually on tests, what happens is they give a quadratic that looks something like this. Yeah, this is just a quadratic. You can tell because there's a squared here. And they only will deal with quadratics in this course, I believe. Like, there's no higher things. But okay, so how do you find the vertex for this is what is going to be shown on the test. So how you do this is you need to transform this form of the quadratic into vertex form, which I'll leave up here, squared plus k. Right now it's in standard form. We need to move it or transform it into vertex form. And to do that, we're doing something called the perfect square trinomial. So this part, it's a lot of my students struggle with this part, but it's always going to be the same steps each time. So just try to follow along, and then you're just going to do the same step every time. So what you're going to do is you're going to take the middle term, it's an 8, right? And you're going to do something kind of weird with it. What you're going to do is you're going to take the number 8 and divide it by 2 and then square it. Don't worry, you're going to do this every single time. So it's just something that you memorize. But when you do this, it's just 4 squared becomes 16. And that I like to call our magic number. So what you're going to do, let me move this to the side first. Oops. Move this out of it. Okay. Gosh, okay. That's our magic number. So what you do is you still write the 8x, and then after you write the middle term, you're going to put the magic number plus and minus. And when you do this, it kind of like, you're allowed to do this because when you do this together, it's just 0. So it never existed in the first place. But it's going to help us transform it to the vertex form. And then what you're going to do next is you're going to add these brackets right here. and then the plus 5, like so. Okay, so now what you need to do is you need to move the negative 16 out of the brackets. In this case, it's pretty straightforward. Because the brackets don't really matter. You can draw them kind of anywhere. But in other examples, in the next example, I'll show you one where it's a bit more complicated, but the steps are still the same. So you move negative 16 out. And now this in the brackets is a perfect square trinomial. So you factor this. Hopefully you know how to factor. If you don't, just search up a video and it'll teach you. But because it's a perfect square, it's not really factoring. It's like, it'll always be the middle number divided by 2. So like x plus 4, as in when 8 divided by 2 becomes 4. So it's kind of like a fake factoring. Okay, and then negative 16 plus 5 is negative 11. So now, I don't know if you can tell, but we actually made it to vertex form. So we have the h value and the k value, which is, for this one, it is 4. But one thing that often people mess up is that it's a negative in front. So the fact that it's positive, you know what? Let me write it in another way that makes it a bit more clear. So x minus the h value is negative 4. And then the k value, well, it stays the same, negative 11. And that's why our vertex is actually negative 4 and negative 11. And yeah, that's just kind of a simple example. So let me go over one more that is a bit harder and usually more likely what will show up on a test. Okay, so like this. So the steps are almost the exact same. The main difference is that we have a 2 in front. So I'm going to start doing, I guess this is the proper procedure to do it. You look at the value in front of the squared, the x squared term, and then if it's if there's something there, you have to divide it out. So you factor out 2 from the first 2 terms. And I know it seems like, oh, why are you doing this? But just like, you just kind of have to keep doing problems and realize that, oh, you're doing this every single time. So it's like, it doesn't matter too much, but like this. It's hard to explain why you have to do this, but you'll see when we get to the final answer. Because it's already starting to look like vertex form, almost. Not really. Maybe if you can see it. But anyways, so now the steps remain the same as the first time, where 6x is our middle number, and we need to find the magic number, if you remember. So I like to call it b, but the magic number is the number divided by 2 squared. It doesn't matter that it's negative. Well, the reason is if you put a negative here, when you put it squared, it's just going to become the same thing. It's just become positive, so you don't need to include it. But here, so 6 divided by 2 is 3. 3 squared is 9. If you're kind of struggling with that, you can just put it in a calculator. So 9 is our magic number. So now we're going to insert it back in. And you insert it right after our middle number, which is negative 6x, right here. plus 9 minus 9, like that, plus 11. That's just from above. And then it's still the same steps as before. So now you have to move the negative 9 out of the brackets. It's kind of why I labeled it as a step, because last time it wasn't really a step, but this time it's a tiny bit more complicated. Not too bad. So here, okay, you need to move negative 9 out and then close the brackets. How you do that is take negative 9, multiply it by what's in front, and then you bring it out. So negative 9 times 2 is negative 18. And that lets you bring it out of the brackets. That kind of blew my mind the first time I saw it, but hopefully it makes a tiny bit of sense to you. So now that we have it in this form, this right here is a perfect square trinomial. So now you just factor it. I'm going to do it how I factor it like this. So just in case you learn factoring the same way I did, maybe I'll do a video later. But if you want me to, maybe leave a comment. But yes, so it's x minus 3 squared. And then if you don't really know how to factor, I mean, it's kind of okay for now, because it kind of follows a pattern. It's always the middle number divided by 2, and then the x stays the same, and the negative stays the same as well, and you just add a squared. Yeah, for this perfect square trinomial stuff, it'll always be like this. So that's why I say you don't really need to know how to factor yet, but it's like, I think it is really important for later on. So yeah, negative 18 plus 11, that's just negative 7. And here we go. Now we have it in vertex form. So if you need a reminder, a x minus h squared plus k, where the vertex is h and k. So what's the vertex of this? It is 3 and negative 7. So the vertex is 3 and negative 7. And yeah, these are common test problems. I can almost guarantee that you'll get a question like this on MC3, oh sorry, what was the course code again? MCR3U, first unit, is usually questions like this.